Hi there, and welcome to Telefunken. Today, we have a really special treat. We're going to be taking a look at a rare synthesizer, at least rare to those of us who live on this side of the pond, the Powertran Transcendent 2000. At first blush, the Transcendent 2000 is nothing special. It's a single oscillator monosynth. It's capable of triangle, ramp, or sawtooth, as we say here in North America, square waves, and pulse width modulated versions thereof. It has a noise generator and a so-called slow oscillator, more commonly referred to now as an LFO, and two envelope generators. One, a simple attack and decay envelope, can be used to control the resonant voltage-controlled filter, and the other, a full ADSR generator, controls the voltage-controlled amplifier. The Transcendent 2000 was designed by Tim Orr towards the latter part of his tenure at Electronic Music Studios, otherwise known as EMS, home of the VCS Synthy and several other famous synthesizers. He designed the Transcendent as a relatively low-cost kit that synthesizer enthusiasts could build themselves. When EMS decided they didn't want kit-built synths dragging down their brand cachet, Tim Orr went out on his own and launched the company Powertran to commercialize his designs. He had a cozy relationship with the magazine Electronics Today International and published schematics, design notes, plans, and instructions for building Powertran synths in a series of articles in the magazine. Although the articles themselves provided enough information for the intrepid do-it-yourselfer to actually build the synthesizer, a much more common approach was for people to order the kits that Powertran offered for sale in the magazine. The T2000 was offered for sale as a kit and in kit form only for the low price of £186.50, which in today's currency would be about $2,200. If you couldn't afford all of that at once, Powertran offered the kit in as many as 12 different packages, so you could buy what you could afford at the time, build it, and save up for the next bit of kit. One of the most famous users of the T2000 was the band Joy Division, who used it extensively on the album Unknown Pleasures. Although Joy Division's T2000 was built by Bernard Sumner, it was also favored by their producer Martin Hannett, who painted his T2000 red. There's been a spate of instruments appearing for sale on eBay claiming to have been owned by Martin Hannett, including at least one T2000, which has led the band New Order to post a buyer beware warning on their website, urging caution when purchasing instruments of dubious provenance. The T2000 on the right is the only one ever to have been owned by New Order, the one built by Bernie, and it's currently in the hands of a friend of the band who lives in New York. The T2000 we have on the bench comes to us from the previous owner, a synth enthusiast in the UK who was the builder of the instrument and owned it for more than 40 years. We don't know much about this unit other than that it has not been used at all in several years. We know that electrolytic capacitors degrade over time and that process is accelerated by a lack of use. As such, we'll be approaching this with caution, specifically verifying the power supply functions properly before turning the instrument on, hopefully thereby avoiding any unnecessary damage to the instrument. Today's video will be the first in a series, one where we will introduce the instrument and show you what we're starting with. Subsequent videos will cover any refurbishment or repair, as well as tuning and calibration of the instrument. In addition, I hope to discuss a potential modification to the gain stage of the instrument in an effort to address what's been described as a signal-to-noise issue. If you're looking for more information on the Transcendent 2000, there are a handful of good YouTube videos on channels such as Synthmania, Look Mom No Computer, Mark Jenkins' channel, and Mindburner, whose channel features classic 80s synths and includes a video he's made describing the T2000. Special thanks to Mindburner for allowing me to sample some of his video in our opening montage. You should definitely check out his channel if you haven't done so already. I hope you enjoy this video. Let's get started. So here on the bench, we have a Transcendent 2000 by Powertran. And this is a synthesizer that many of you may not have seen before. It was a synthesizer that was sold in kit form. So this was built by the end user as opposed to being built in a factory. And I've just acquired this from overseas. I purchased it from the United Kingdom where these were marketed and this was built. And I wanted to give you a bit of an introduction and a tour before I set about to refurbish this. The instrument was built in around 1978. And so that makes it, again, more than 40 years old. It is in a wooden chassis with some metal elements, including this front panel, which obviously was part of the kit, and it's an aluminum panel with black printing on it, and then the labels and the like are the aluminum that has not been printed on. So as opposed to having, say, white paint on black. That panel covers the main printed circuit board, which contains the synthesizer itself, and the power supply and various other elements are mounted on the back panel. So you can see it in all of its glory. It is a monophonic synthesizer containing a number of integrated circuits. Most of these are op-amps or OTAs, operational transconductance amplifiers. And other than that, relatively few parts, a few transistors here and there, a few capacitors, very few electrolytic capacitors. I see only two really on the top surface of the main PCB. Two electrolytic capacitors, a few tantalums, and that's really about it. Very simple design. I'll give you a quick flyby with the camera to give you a little bit better view of the printed circuit board, and then we'll flip it over and look at the inside of the instrument. So in order to get access to the other side of the PCB, we simply flip the instrument on its side and remove the metal panel that covers the bottom, which I've already done for the sake of expediency. And I won't be able to put the synthesizer on its face because the potentiometers protrude from the face. But this gives you a bit of an idea of what it looks like from the bottom. And I'll simply set it on its side and we'll examine it from there. So here's a view of the Transcendent T2000 on its side. And this gives you a bit better view of some of the unique aspects of the synthesizer. One of which is this rather unusual keyboard assembly, which is comprised of a number of reed switches, 2 reed switches per key, which are actuated by these plastic actuators. This is a part of the instrument that needs to be assembled when you actually make the kit. And so it's been done with various degrees of effectiveness by the various assemblers of the instrument. It involves actually gluing these reed switches onto position on a bracket that then all gets assembled. This keyboard seems to be in pretty darn good shape, with the one exception being maybe that this one reed switch right here, I've just moved it back into position, the actual brass rod that activates the reed switch when the key is pressed was out of position. And you can see as I move, as I press a key, hopefully you can see the 2 rods or reeds moving in unison, and that has to be coordinated. Otherwise, the gate is sent at the wrong time relative to the control voltage for the pitch, and you get mistriggering of notes. And so all of these need to be synchronized so that they're playing in the appropriate order. So that's one very unique aspect of this whole thing. Another odd aspect of this is this hinge here. And I've noticed this in some of the other, some of the videos that I've seen on YouTube and whatnot, that this hinge seems to be part of the keyboard mechanism. And I'm really not sure what it's for. It, by all appearances, would seem as if this is meant to be bolted down somewhere and allow you to gain access to the keyboard somehow, but not in this particular application. So again, I don't really know what's up with that. We have here the power supply for the instrument, but I'll describe how the power comes into the instrument. This again is a instrument manufactured in the United Kingdom, so it's wired for 240 volts, I would imagine. This is the power cord and the plug that comes with it, which is not the modern version of this sort of plug that you would find on an instrument in Europe, but it is fused at the plug, which is something that you'll find in European plugs. And it's polarized by virtue of there being a ground plug. The power comes in here, and one lead goes to a fuse, the other lead goes to the switch, the other lead is coming out of the fuse, and both are switched. So this is a double pull, double throw switch, which is probably best for safety. There is a ground lead, which is grounded here onto the chassis of the instrument. Maybe not the best ground, but it'll probably suffice. And then the power goes to a transformer here, which is insofar as I can tell, has two windings, because there's a little wire here on what appears to be the primary side that jumpers to connectors on the transformer. And I think it even says 110 on there. I can't see it from here, from this angle, but that would suggest to me that this is a dual winding transformer, and we can convert this to 110 volts or 120 volts, which would be great. It means we don't have to buy a new transformer. So that'll be one of the first things that I'm looking into, because I'm rewiring this for North American standards. So I'll use this fuse, etc., the fuse holder rather, and the switch. And then hopefully the transformer, after the voltage is transformed, reduced in voltage, comes over here to the power supply section, where it is rectified, filtered, and then regulated to plus and minus, I believe it's 12 volts in this instrument, which is a little low in my mind, but with respect to the standards available at the time in 1978, I think there was maybe less emphasis on squeezing the most out of op amps and making sure that you had high fidelity in an instrument like this. So yeah, we may have lost a little bit of headroom by using a lower power supply voltage, but hopefully that won't hurt us in any way, but we'll examine that a little later. So then once the power supply has converted the various voltages, these voltages go from the power supply board to the main circuit board, which has the synthesizer itself. And then the synthesizer is connected to a back panel, the rear panel of the instrument, through this cable here, which has 5 wires running through it, one of which is a shielded output, I presume. And that goes to the back panel here, where there are a number of jacks for high and low output, VCF in, external gate in, external CV in, and a control pedal, which is meant to modulate the filter. And these are all mounted on the back panel of the instrument, which if I turn it around, you'll be able to see here. So again, fuse holder, lit switch, and many, or rather 6 jacks on the back side. The keyboard itself has 1, 2, 3, 4, 5 connectors or wires running to it. I'm going to assume one's positive, negative power. One is likely ground, and then the other 2 wires are likely going to be CV, the control voltage out, and the gate signal coming out, which or the trigger signal, which will be converted into gate. And again, this is a sort of a voltage divider type keyboard assembly where the control voltages are determined by these precision resistors, which we'll have to check and make sure they're all within specification. This is a kit, and we can tell if we look at the soldering that it was done by hand, and it looks to have been reasonably well done. There's a bit more flux remaining on the board than I might prefer. Whether or not the assembler actually removed the flux or not remains to be seen. Or I'm not sure if that was standard practice back in the day, but nowadays we like to remove our flux and have a nice clean board. Although there's really not a lot that the flux is doing in a negative sense for us, other than maybe attracting a little bit of dirt and looking unseemly. Other than that, it's not harming anything. The potentiometers all appear to be the same basic design, and they even say made in the UK on them. Don't know how many potentiometers are made in the UK now. The potentiometers do appear to have an opening at the back that we could use to spray in cleaner if we need to clean them, and they appear to be a style that could be disassembled as well if that is deemed to be necessary. So first things first, what I'm going to do is cut off this power cord, put on a new power cord, and then start to assess the power supply. It's likely that at the very least it'll require new caps, which is fine. But hopefully the power supply itself is actually working, and we'll go from there. That'll also involve rewiring of this transformer. The case is in very good condition, given its age, although there are a few scratches on the case, on the wood, and you can see some of these, but other than maybe penetrating the varnish on the outside, I don't think any of them go too terribly deeply. So I may try treating the outside of the instrument with lacquer thinner as a means of getting out some of these scratches and smoothing them, rather than trying to refinish it. Other than that, the instrument appears to be in really good condition. I haven't done anything other than remove dust and grease that had accumulated around the potentiometers, and I brushed off the dust and dirt and blew out the switches, but I haven't even begun to approach it with, say, contact cleaner or anything else of that nature. That will be forthcoming after I determine that we can actually get power to the instrument. So there you have it, a somewhat untouched version of Transcendent 2000, which I thought I would document before leaping in and disturbing it at all. So I hope you found this interesting, and stay tuned for more.